Hello, welcome to In 5 Minutes. Next problem tells us to find the value of ICQ and VCQ, that is nothing but the Q point for the potential divider biasing circuit. So what we can do for the potential divider biasing circuit is we can reduce the circuit by finding the equivalent resistance called Thevenin's resistance and Thevenin's equivalent voltage. Now how to find the RTH and VTH? For that we need to apply the potential divider rule. You know the potential divider rule. You have the resistance. Now for this circuit can be drawn as you have R1 and R2 resistance. You need to find VTH at this point. So by potential divider rule we can find the value of VTH as R2. The resistance across which we want to find the voltage will come in the numerator. So R2 upon R1 plus R2 into VCC. So this will give you the value of VTH as 4.186 volts. Now to find the value of RTH, what we are doing is the voltage source, or that is 18 volts, is now replaced with a ground. This is similarly how we find the Thevenin's equivalent resistance. Volt sources are grounded and current sources are open circuited. So all voltage sources are grounded. We can find the value of RTH. So when you look at the diagram, you need to find RTH between these 2 points. So what you can say, there are two resistances R1 and R2 across which we need to find the total resistance RTH. So this is nothing but the parallel combinations of R1 and R2. So RTH is nothing but R1 parallel R2. So this is how you can find the value of RTH. So in this case it will be 33 kilo ohms in parallel with 10 kilo ohms. Now how you can solve this is, you can simply put 33 inverse plus 10 inverse and the whole inverse in the calculator. That will give you the parallel value of the resistance. So this will come around 7.674, but since you are not considering kilo over here, so you need to write it as kilo ohms. So this is how we have found the value of RTH and VTH. Now since we know VTH and RTH, we can find the value of IBQ. How? When you apply KVL in the base loop, when you look here, when you are applying KVL in this loop, what will be the equation? Total voltage is VTH minus voltage at this point is VBE, you can say. So now when you apply KVL in this loop, the equation will be negative positive, you have positive negative, you have positive negative VBE and positive negative. The current flowing through RE is IE, current flowing through this is IB. So when you apply KVL in the base emitter loop, KVL to base emitter loop, the equation will be VTH minus IB RB minus VBE. RB is nothing but your Thevenin's equivalent resistance. RTH minus IE can be written as 1 plus beta IB, right, into RE equals to 0. Now in this you know the value of beta given in the question. What all values you know? VTH we have found, then RTH we have found, VBE 0.7, IB we don't know, RE we know, and beta we know. So in the shortcut method you can write the equation. How you can write the equation? IB equals to total voltage. How many voltages are there? VTH and VBE. So VTH minus VBE will come in the numerator. In the denominator you will have total resistances. RB is in the base but RE is in the emitter, so you need to move it into the base. So multiply it with 1 plus beta, that will give you the total resistance. So IB from this you will get it as 59.41 microamperes. This is how you have found the value of IB. So you can find the value of ICQ as beta times IBQ. You know the value of IBQ, so ICQ will be 2.97 milliampere. This is how we have found the value of ICQ. Now in order to find the value of the VCEQ, how you are going to find the value of VCEQ? You need to apply KVL from the collector to ground. How you are going to apply KVL? From this point to this point you will find the equation. So what will be the equation in that case? You can write VCC minus ICQ into RC minus VCEQ minus IEQ into RE equals to 0. So this will give you VCEQ as VCC minus ICQ RC minus IEQ into RC. We have found all these terms, so you can find VCEQ easily as 8.436 volts. This is how we have found all the required parameters in the question successfully.